Okay, welcome again to the in continuation with the syntax directed translation topic. So we'll see some of the examples related to SDT. So let's see the grammar. S tends to, let's say it is XXW, and it is saying that it should printf 1. So the action for this is printf 1. Okay, there is inverted quote and everything, right? So this is one thing. Then we are having or y, which is saying printf 2, and there is one more line which is saying w equal to, there is sz, right? So sz, which is printf 3. So the question is, if there is some input string available with you, and that input string is let's say for some input string, let's say x x x x, and let's say y z z. So these are that means 4x and then y z z. So the question is, what is the output printed if we take the given string and apply on given SDT, right? So what will be the output that will be printed for this SDT? So this is the question which is supposed to be solved, right? So what we have to do is again, we can use any of the parser, that is bottom up parser or top down parser. So what we will do is, again, we will use LR parser, which is bottom up parser, and we will have to prepare the parsing table for that. So we'll note down this, and we will be preparing a parsing table, and again, depending upon the various reductions which would be possible, what will be the outcome? That is what is expected as an outcome, right? So we will prepare the parse tree for this grammar, right, and for this input stream. So note down x x x x y z z. Okay. So what will be the parse tree for this? So S is equal to, we know the productions which are S equal to X, X and W, right? X, X and W. And we are having this W, which is further, it could be S or Z, right? We want what? X, 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 Y, Z, Z. Right. So this is what is the input string, and for this input string, we need to prepare the parse tree for this. Right. So again, we know that there is a production which is S tends to XXW. So we can say S tends to XX or W. Right. And again, this W. So we are now having 4X available here, and then we need that Y and Z also to be there. So to have this Y and Z, so this W could be further, for which there is a production which is W tends to S and Z. So this ZZ is done, and we know that S tends to Y. There is a production which is tending to S tends to Y. So this is there, right? So if you see, if you traverse from top to bottom and left to right, and then you will get this yield as, you will get this yield which is XXXX Y ZZ, right? So again, just see, I'm noting down the productions. So this was the production or Y, and this was W tends to S Z, right? So using this production, we have prepared the appropriate parse tree, right? And now using the bottom-up parser, that is, let's say LR parser, which is a bottom-up parser. So in the bottom-up parser, we have seen that there will be reductions which we will be searching for, right? So in the reductions that we are searching for, what is going to happen is we will start traversing the entire tree, and what will happen is it will reach here, right? So this is the first place where, this S tends to Y. So this is the first reduction which is going to take place, right? So S tends to Y, and when there is S tends to Y production, what is there is, it is printing 2, right? So it is printing 2. This was printing 1. that was the action, and printing 3 here. So when s tends to y production is there, so it is going to print 2. So 2 is printed because of this, right? So printing 2. Then this is going to continue here, and this is where the SW equal to SZ is going to be a reduction operation here. So the second reduction operation is W tends to SZ. W tends to SZ is saying print 3. So 3 will be printed here, right? And then this is going to continue here, and what will happen is S tends to XXW. So we know that S tends to XXW, it has to print 1. So it will be printing 1 at this reduction, right? Then again it has to continue here, and what will happen is W equal to SZ. We know W equal to SZ is 3. So 3 will be printed because of this reduction. And again, it will be reaching to the start location. So S tends to XXW, which is saying that you have to print the location, the value 1. So this is going to print the value 1. So what is the output? Output for the yield, which is XXXXYZZ. Output which will be printed on the screen is 23131. So in this way, the questions may come up in front of you in the gate. So you should be able to address this type of questions, right? So in the next example, we will see. We'll examine in similar way the different types of questions. Let us see the other question. Okay, so let's say I'm giving you just examine the grammar. E tends to E star T. Let's say E1 star T, and what it will do is E dot well is equal to E1 dot well star T dot well. T dot well. Okay, so that attribute. Then or T. So this is nothing but E dot well is equal to T dot well. Just note down this. And T tends to F minus T. See, there is some difference here. F minus T, right? So let's say T1. Okay. So what will happen is T dot well is equal to F dot well minus T1 dot well. Okay. And is or F. This is T dot well is equal to F dot well. Okay. Then F tends to 2 and or 4. So these are the two attributes which are directly associated with this. So F dot well equal to 2 and F dot well equal to 4. Okay. So these are the things, let's say, if you have noted down, please note it down. If you not noted down, there are no tokens, understand here, there are no tokens here, directly numbers are given to you. So lexemes are the token itself here. And if you look at the precedence of the operators, the plus operator and the minus operator, there are two operators which are present. And plus operator is near the start, so it is having low priority, but star is minus is having, it's far away from the start symbol, so minus is having higher precedence compared to star. Okay, so as far as precedence is concerned, minus is having higher precedence compared to star. As far as associativity is concerned, this left hand side symbol is available on the left hand side of the star, so it is left associative. And when we see minus, if you see T is associated, left hand side symbol T is available on the right hand side. So minus is right associative and star is left associative. Okay, as far as precedence is concerned, star is having low priority and minus is having higher priority. Okay, given to you this situation, now the question is you need to solve what will be the value of the string. Let's say W is given to you 4 minus 2 minus 4, just note down, and then star 2. I'm going to put up some brackets there, here and there. Okay, so what is the situation is 2 minus 4, this is going to be there, and 4 minus 2 minus 4 into 2, right? So Okay, and this one is there. Okay, so what will be the situation? Which one will be evaluated first? So we know that the minus operation will be evaluated first, right? So if you look into the graph and try to solve it, you will be in a situation to know that this operation will be evaluated first. Okay, then minus, why? Because I'm saying right hand side minus operation has to be evaluated first. So right hand side will be evaluated first. Then again, this 4 minus this operation will be evaluated at the second level, right? And the third operation would be your multiplication operation. So in that way, it is going to be there near the okay, and the third operation would be your star operation. So this is how the operations are going to be handled. So what will be the outcome of this is, so 2 minus 4 is minus 2. What I will do is I will rub this out and we'll try to see this. So 2 minus 4 is minus 2, and 4 minus this is this operation. So this is nothing but 6, right? And then this operation is multiplied by 2, right? So this is how the first operation is minus 2, second operation is 4 minus, that is this 6 value. The third operation is multiplied by 2, that is going to give you answer as 12, right? So now if I say I want to continue, I want to find out how many number of total reductions are there. So if I continue with this question, then how many reductions are there? So in that case, you need to identify. I mean, you need to first of all draw the pass tree for this expression, and you'll have to draw the pass tree, and then you'll have to see how many reductions are possible, right? So we'll draw the pass tree first for this expression, and then see. So it was 4 minus 2 into 2, right? So this was the string which was there. W is equal to this into this. I mean this operation. So what will be the pass tree using the above grammar? So that pass tree for this expression would be something like this: E equal to E star T. Then this operation is finished. So T star F and then number, because star operation is there. So T star F and F tends to number, that was 2, right? So we are having only two numbers. F is pointing to 2, F is value of 2 and F is value of 4, right? So now E equal to E minus E tends to T operation is possible. So E tends to T, and then T tends to T minus and T minus sorry, F minus T. So this is F minus T. So just see the grammar. What was the grammar? E tends to E minus T, E star T or T, and it was T tends to F minus T or F, and F tends to 2 or 4, right? So based upon this, T tends to F minus T. So T tends to F minus T, and then again this minus 2, so T tends to F minus T is possible, and then T tends to F and F tends to some number, right? So in that way, what are the various numbers which could be there is 4, 2 and 2, right? So am I doing some mistake here? 4 and then 2 minus 4. So it was 2 minus 4, 2 minus 4. If I've done mistake in the previous one, have I done any mistake in that previous expression? However, it was 2 minus 4, right? So just correct it if you have given I've given you some wrong numbers. So 2 and then this was 4, okay, and this is 2 here, okay. So this is the pass tree for this string expression, and now the question is how many count the number of reductions considering the above SDT, right? So we were having the SDT for this, right, and using the bottom up parsing. So what is the solution for this? So all the non-leaf, all the non-leaf are the reduction. So if you see here, how many reductions would be there? how many reductions would be there? 1, 2, 3, 4. These are all reductions which are going to be there, right? F tends to number is a reduction. So then once this is assigned, then after if you see at every place there is a reduction operation which is going to be there. 4, then 5, 6, 6 here, 7, 8, 9, and 10. So there are 10 non-leaf elements, right? This is one, so forget about this. So there are 10 non-leaf elements. So total number of reductions which would be possible in this case would be 10. So answer to this is 10. Okay. So now we have seen 2 examples related to the expressions, and continuing in the similar direction, we'll go ahead with one more example, and then we will have a break. Okay, so example is I'm giving you one grammar E tends to E hash T or T, and I'm giving you T tends to T and F or F in similar lines. No, the previous grammar was there. So F tends to number, and what is the action part? Action part is E dot well is equal to, just note down with me, E dot well star T dot well. So wherever there is a hash, there is some star operation which is going to be done, right? Operation which is required, and E dot well equal to T dot well. Then T dot well is equal to T dot well, and for ampersand there is plus operation which is supposed to be there. So F dot well and then semicolon, and T dot well is equal to F dot well. Okay. Then this F dot well is equal to number dot L well, lexical value. So whatever the value is there, that value will be directly given to the number F. So now the question is, if I'm giving you 2 hash 3 and 5 hash 6 hash 6 and 4, right? So what will be the final value of this, right? I hope you are able to well, look at it properly, right? And so what you are supposed to do is, wherever there is hash and wherever there is end, you see there is star and plus, which are these are the operations which are supposed to be done, right? So what I will do is I will simply convert this into the appropriate action part with operators of the action part, right? So that becomes easy for me. So 2, wherever there is hash, I will say it is star, and whenever there is ampersand and, I will say plus, right? So again star, then 6, and ampersand end is plus 4, right? So again, plus operation is having higher precedence, so it will be evaluated first. And what is going to happen is, whenever this is going to be seen, it will be evaluated, and then the next operation that will be evaluated would be 6 plus 4, right? So what is going to happen is, this is 8, and 2 into 8 into 10 operation. No, this is how it's going to be there. So it's 8 into 2 is 16, into 10 is 160. So answer would be 160. I hope you are getting this, right? So what we have done is, we have just given to the input string where the hash was there and the ampersand end was there. As per the this syntax directory translation action, so it has this hash has to be replaced by star, and ampersand end has to be replaced by plus. After doing this, look at the operator precedence. So plus has to be evaluated first compared to the star operation, because this is at the lower level. So plus operation will be done first. So both the operation of the plus is evaluated. So this is coming to 8 and this is coming to 10, and finally we will get 160 as the outcome, right? So in this way, we have seen some of the numericals related to the SDT on the expression. In the subsequent topics, we'll see more examples related to it in a better way.